Mathematics Alive. This is Geometry Lesson 3, Angles and Angle Pairs. Let's start with definition of terms. Definition number 1, angle. An angle is the union of two non-collinear rays with a common endpoint. And we will be representing an angle with this visual aid. So the common endpoint is here, and the two non-collinear rays are these two. And the rays are called the sides of the angle. The common endpoint is the vertex of the angle. Definition 2, angle measure. The measure of an angle is the amount of opening. So the amount of opening is here of the angle, and it corresponds to a unique number between 0 and 180 degrees. When we say between, it doesn't include the 0 and it doesn't include the 180 degrees. So it's just between the two values. The amount of opening of an angle is measured using a protractor. So here is a protractor, and we will be measuring this angle using this protractor by putting the vertex at the center of the protractor, and then we have the 0 point here, 0 point, and this measure represents 60 degrees. So you have an opening of 60 degrees for this particular angle. So definition 3, adjacent angles. Two angles are adjacent if they have a common vertex and a common side. So we have here a common side of two angles and a common vertex. So these two angles are adjacent, and you can increase the measure. Okay, these two angles are also adjacent angles. You can also increase further. Okay, so these two angles are adjacent, and we can also use this. Okay, so these two angles are adjacent angles. Definition 4, acute angle. If an angle has a measure of less than 90 degrees, then it is acute. So this is less than 90 degrees. And you can increase that to just a little bit less than 90 degrees. And it's still an acute angle. Then definition 5, obtuse angle. If the angle goes beyond 90 degrees, then it is already obtuse. So this angle is an obtuse angle. And if it is exactly 90 degrees, then it is a right angle. A right angle has a measure equal to 90 degrees. Congruent angles. Two angles are congruent if they have equal measures. In symbols, the figure angle A is congruent to the figure of angle B if and only if their measures are equal. Their measures represent a number or numbers in terms of degrees. And the figure are not numbers, they are actual figures. So we use congruent symbol for figures and equal symbol for numbers in terms of degrees. Definition 8, vertical angles. These are two non-adjacent angles formed by two intersecting lines. So, vertical angles are formed by two intersecting lines, and you can imagine a pair of scissors or this illustration. Okay, so two intersecting lines form these vertical angles, the non-adjacent angles. And these two angles are also non-adjacent, so they are vertical angles. Complementary angles. Complementary angles are two angles, the sum of whose measures equals 90. They may be separate or they may be adjacent. As long as their sum is 90 degrees, they are complementary. Theorem 1, angle complement theorem. Complements of congruent angles are congruent. So let's prove this theorem. Given angle 1 is a complement of angle 2, so these two form 90 degrees, and angle 3 is a complement of angle 4. And it is also given that angle 2 is congruent to angle 4. So we are going to prove that angle 1 and angle 3 are congruent. To give a proof of a theorem, we lay down the statements in a logical order, beginning with the given facts. And the given facts are forming the evidences of your case. It's like proving a case in court. You give the evidences and then let the judge decide if your evidences are convincing before he gives the judgment or the verdict. So in proving a theorem, you give the statements in a logical order and give reasons for each statement. Number 1, angle 1 is a complement of angle 2, angle 3 is a complement of angle 4, and these are both given. Number 2, since angle 1 and 2 are complementary, the sum of the measures is equal to 90 degrees. Also, the measure of angles 3 and 4 is equal to 90 degrees. It is by definition of complementary angles. And then since both of them are equal to 90 degrees, the left side of these two equations can be equated. So measure of angle 1 plus measure of angle 2 is equal to measure of angle 3 plus measure of angle 4. What particular property was used here? Okay. It is transitive property of equality. Then it is also given that angle 2 is congruent to angle 4. So the measures of angle 2 and angle 4 are equal by definition of congruent angles. And if we subtract the measures of angle 2 and angle 4 from both sides of this equation, what is left is measure of angle 1 is equal to the measure of angle 3. And we use addition or subtraction property of equality. And since the measure of angle 1 is equal to the measure of angle 3, therefore, angle 1 is congruent to angle 3 by definition of congruent angles. And we have just proven the angle complement theorem. Corollary to that is, if two angles are complementary to the same angle, then they are congruent. Definition 10, Supplementary angles. Supplementary angles are two angles, the sum of whose measure is equal to 180 degrees. Again, they may be non-adjacent angles as long as the sum is equal to 180 degrees. Or they may be adjacent angles also. Theorem 2, Angle Supplement Theorem. Supplements of congruent angles are congruent. The proof of this theorem is very similar to the proof of Theorem 1. You simply have to change the sum and the words complement to supplement and the sum of the two angles to 180 degrees. Corollary 2, if two angles are supplementary to the same angle, then they are congruent. Definition 11, linear pair. Two angles formed by any two adjacent angles which are formed by the union of a line and a ray forms a linear pair. And I will illustrate that with this. I'll form first a line and a ray. So I'll try to make this straight, and this part is another ray. Okay, so this is the common side and this is the line. So we have here a linear pair, and the sum of the angles here will be equal to 180 degrees. That's the linear pair postulate. The sum of the measures of the angles in a linear pair is 180 degrees, meaning linear pairs are supplementary. Theorem 3, vertical angle theorem. If two angles are vertical, then they are congruent. Look at this illustration. We're given two intersecting lines forming angle 1 and angle 2, which are vertical angles, and angle 3 is a linear pair with angle 1. It's also a linear pair with angle 2. So we will prove that angle 1 is congruent to angle 2. First, let's start with a given. Angle 1 and angle 2 are vertical angles, given. Then, angle 1 and angle 3 form a linear pair. And angle 2 and angle 3 are also a linear pair. So, by definition of linear pairs, we have seen in the drawing that they follow the definition. 1 and 3 form a linear pair, and 3 and 2 form a linear pair. And therefore, angle 1 and 3 are supplementary angles. And angle 2 and 3 are also supplementary angles by the linear pair postulate. And since they are supplements of the same angle, therefore, angle 1 is congruent to angle 2. By corollary 2, supplements of the same angle are congruent. And we have just proven the vertical angle theorem. Definition 12, perpendicular lines. Two lines are perpendicular if and only if they intersect to form a right angle. Theorem 4, perpendicular lines theorem. If two lines are perpendicular, then the pairs of adjacent angles they form are congruent. In fact, you have 4 pairs of adjacent angles here. So we have one pair, then another pair, then we have another pair here, and the last pair is from here to this. Corollary 4.1. If two lines are perpendicular, then all four angles they form are perpendicular. Again, it's quite obvious. Corollary 4.2, right angles are formed at the foot of two perpendicular lines. This is a very important corollary because we will be using this in many proofs of theorems and problems which involve right angles and right triangles. Theorem 5, all right angles are congruent. Definition 13, perpendicular bisector of a line segment. It is a line, a ray, or a segment that is perpendicular to a line segment at its midpoint. So the line segment AB is being bisected by the perpendicular bisector of the line segment. And the point M is the midpoint of the line segment AB. Definition 14, the line perpendicular to a plane. If you look at the illustration here, we have the line T perpendicular to the plane L at point P. A line is perpendicular to a plane at point P if and only if it is perpendicular to every line on the plane that passes through P. And we have represented the line on the plane by two lines, CD and AB. CD is perpendicular to T and AB is also perpendicular to T. Therefore, T is perpendicular to the plane of the two intersecting lines AB and CD. Definition 15, perpendicular planes. Two planes are perpendicular if and only if one plane contains a line that is perpendicular to the other. So the plane P sub 1 is perpendicular to the plane P sub 2 because the plane P sub 1 contains a line which is perpendicular to the plane P sub 2. And that's all for lesson 3. In my next video, I will demonstrate 5 basic constructions in geometry. Please like, share, and subscribe to Mathematics Alive by clicking to the button below. Bye-bye.